so now let's review for what we did, what we learned over the week. Now, to begin with, we have permutations and combinations. So, question number 17, we have five. So, let's take a look. The way I'm going to do this, using the five in there, the first number, I'm just going to write 5 on top of my fraction. Then, subtracting my two numbers, 5 minus 2, I get 3. So, at the bottom, I'm going to have 3 factorial. So, once again, the 5, I just did it on the top. For the bottom, I did 5 minus 2. That's how I got the 3 factorial. Right? I did factorial on each. So now what does 5 factorial mean? It's 5 times 4 times 3 times 2 times 1. So starting at 5, going with your whole numbers all the way down to 1. So I'm just going to start with 5 times 4 times 3 factorial. Instead of writing 3 factorial as 3 times 2 times 1, I left it as 3 factorial. And the reason why I left it as 3 factorial because we have a 3 factorial at the bottom. So they cancel out. So I have 5 times 4. So I'm just going to say this is 20. Now looking at number 18, I'm going to write this as 5 factorial over 2 factorial. The 2 factorial from the bottom because I went 5 minus 3. So the way I'm going to do the 5 factorial, let me write this as 5 times 4 times 3 times 2 factorial. Notice I stop at the 2 factorial, and the reason why, because I have a 2 factorial at the bottom. So they cancel out. So now I have 5 times 4 times 3, and that happens to be 6. Now for combination, the difference between permutation and combination is the order does matter in permutation. In combination, it does not. Some people call it choose instead of combination. So the way I'm going to do this, I'm going to start the way I do permutation. I'm going to start it similar. I'm going to do 18 factorial on the top and 4 factorial at the bottom, kind of like how I do permutation. You see that 18 from the first number, my 4 factorial because I subtracted my numbers 18 minus 14. So like I said, almost like we do permutation. The only difference is that in this case, I'm also going to include a 14 factorial at the bottom. My second number, I have it at the bottom. So all right, 18 factorial. That is 18 times 17 times 16 times 15 times 14 factorial. Notice I'm stopping at 14 factorial because I have a 14 factorial at the bottom. All right, so I already did my 14, already did my 18 factorial. Now my 4 factorial, what does that mean? That is 4 times 3 times 2 times 1. All right, so let me get a calculator. For the top, on the top I have 18 times 17 times 16 times 15. On the top, I have 73,440. At the bottom, I have 4 times 3 times 2 times 1. That's 24. Now, let me get my calculator out again. Let me find out how much is 73,440 divided by 24. And I get 3,060. Now, if you just type in the digits, 3060, that'll be okay for the homework if you just type in the digits. But if you put in your comma, because you were told to separate comma for every 3 numbers, that would be okay as well. The little comma is optional. Now let's take a look at question number 20. 17 combination forward, or like how people say sometimes 17 choose forward. I'm going to start this by calling this 17 factorial over 13 factorial. But at the bottom, I'm also going to have a 4 factorial. All right, so let's see. On the top, I have 17 times 16 times 15 times 14 times 13 factorial. I stop at 13 factorial because I do have a 13 factorial at the bottom. And then my 4 factorial, let me just call that 4 times 3 times 2 times 1. So the 13 factorials cancel out. All right, so on the top, I have 17 times 16 times 15 times 14. That gives me 57,120. 4 times 3 times 2 times 1, we just did that in the previous question. I know that's 24. So I'm just going to go 57,120 divided by 24 equals 2,380. 2,380. I said the little comma was optional. I wrote it in number 19. In this case, I'm not going to write it in number 20. Like I said, the little comma is optional. All right, let's take a look at number 21. 21 and 22 says, state if each scenario involves a permutation or a combination. Permutations when order matters, combination is when it does not matter. Then find the number of possibilities. Joe and Imani are planning trips to 3 countries this year. There are 5 countries they would like to visit. They are deciding which countries to skip. All right, so from 5 countries, they're going to go to 3. I don't see anything about order. Basically, from 5 countries, they're going to choose 3. Right? Remember, I said combination. Some people call it choose. So I'm just actually going to say, well, this is combination. Then find the number of possibilities. I'm just looking at 5 countries. They're going to choose 3. So I'm just going to see this as 5 factorial over 2 factorial, 3 factorial. So that I'm going to see that as 5 times 4 times 3 factorial. I have a 3 factorial at the bottom. And then my 2 is just 2 times 1. So I have 20 over 2. So that's 10. Now, question number 22. A team of 15 softball players needs to choose a captain and a co-captain. So there's an order about positions. It doesn't matter whether I choose captain first or I choose co-captain first, but there is an order. Right? I'm choosing for 2 different positions. So I'm just looking at 15 permutation 2. From 15 people, I'm going to choose 2 people for different positions. So I just said this deals with permutation. All right, so here I'm just going to say, I'm going to call this as 15 factorial over 13 factorial. Now 15 factorial is 15 times 14 times 13 factorial. The bottom I have 13 factorial. They cancel out. Now 15 times 14. Let me grab my calculator. 15 times 14 is equal to 210. Now looking at question number 23. Find the probability of each. So a shipment of 9 smartphones contains 2 with cracked screens. So there's 9 phones, 2 of them are cracked, and obviously 7 are not. If sold in a random order, what is the probability that the first 7 sold have undamaged screens? So it does matter, right? There's an order that matters. There's 9 phones, and I want to sell the first 7 to be the ones that are not cracked. So I'm just going to do this as 9 permutation 7. What's 9 permutation 7? 9 factorial over not 9. See this real quick. I'm actually going to do 9 permutation 2. The order thing is how many from the 9 phones that I have. I'm looking at the 2 that are cracked, right? 9 permutation 2. So I'm just going to look at this as 9 factorial over 7 factorial. So that is 9 times 8 times 7 factorial over 7 factorial. So I'm going to say, well, there's 72, right? 9 times 8 is 72. 72 possible ways I can do this. Now I have 2 crack phones, right? Remember, I'm going to sell them in as a number 8, and number 9. Now, how many ways can I rearrange 2 phones that are cracked? I can sell, if I was to sell all 9, right? I can sell one cracked and then the other, or I can sell the other and then there's the first one. That means I can put, how many ways can I arrange 2 phones? I can arrange them in 2 different ways. Now, 2 over 72, that is simplified as 1 over 36. Looking at question number 24. One day, 10 babies are born at a hospital. Assuming each baby has an equal chance of being a boy or girl, what is the probability that at least 2 of the 10 babies are girls? So I'm looking at what's the probability of being at least 2 of them are girls. I'm looking at what's the probability that 2 of them are girls. What's the probability that 3 are girls? What's the probability that 4 are girls? 5, 6, 7, 8, 9, 10. That's too many probabilities to add. Why don't I look at how many ways I can rearrange this? So I say, well, the probability of being a boy is 1/2. The probability of being a girl is 1/2. So I'm going to say 1/2. And then I want 2 and 8. So there's basically 10 babies. So I have 1/2 to the 10th power. Now that gives me 1 to the 10th is 1. 2 to the 10th, so 2 multiplied 10 times, that is 1024. All right, so I have 1024 probabilities. How many ways can I rearrange this? Remember, I want to say, well, I don't want to look at probability of 2 of them are girls, 3, 4, 5, all of them. Instead, let me look, what's the probability that 0 are girls? What's the probability that 1 of them are girls? And whatever I get from those 2, I'm going to subtract them. I'm going to subtract them from 1024. All right, so for the first one, I'm going to say, well, 10 choose 0. And for the second one, I'm going to say 10 choose 1. All right, so how do I do this? I'm going to go 10 factorial over 10 factorial, 0 factorial. The 10 factorials cancel out. 0 factorial is 1. I cannot leave the top empty, so the probability that 0 are girls is 1. Now, probability that 1 of them is a girl, so 10 choose 1. I'm going to say this is 10 factorial over 9 factorial, 1 factorial. So I have this as 10 times 9 factorial, but 9 factorial at the bottom, and then 1 factorial is just 1. So 10 over 1 is just 10. Okay, so once again, I have 1024 possible ways this kit can be formed. So 1024. From those 1024, I'm going to subtract the 1. What's the probability of 0 girls? And I'm also going to subtract 10. What's the probability that one of them is a girl? So 1024 minus 11. 1024 minus 11 gives me 1013. Now, lastly, let's take a look at questions 25 and 26. Let me give myself some room to work here. So we called this yesterday the binomial theorem. All right, so the fifth term in the expansion of n plus 2 to the 7th. Okay, so the way I'm going to do this, I'm going to do 7, choose 5. Let me give myself some room to work. Now, starting at 0, all the way to 7. So 0, 1, 2, 3, 4, 5, 6, 7. I'm asking which is my fifth term. So in this case, I'm going to do 7, choose 4. Then I'm going to say n and 2. You guys see my n and my 2. All right, what's 7 minus 4? Starting at 7, because that's my highest exponent. And my key number here is 4. 7 minus 4 is 3. And then here I have a 4. So I'm going to do this. What's 7? Choose 4. 7, choose 4. I have as 7 factorial over 3 factorial, 4 factorial. So 7 factorial, 7 times 6 times 5 times 4 factorial. Have a 4 factorial at the bottom. My 3 factorial is 3 times 2 times 1. 7 times 6 times 5, that's 210. 3 times 2 times 1, that's 6. 210 divided by 6 is 35. This is 35. N to the third is just n to the third. 2 to the fourth, that is 16. Let me multiply my numbers. 16 times 35. 560. So I get 560 n to the third. For number 26, let me switch to red. That way we don't get confused. Starting at 0, I'm going to count to 7. So 0, 1, 2, 3, 4, 5, 6, 7. I'm asking which one's the fifth term. So I'm going to do 7, choose 4. My two terms are y and x. You guys see my y, my x. Notice on my x I wrote it positive. Keep the sign that it's in front of it. Now, 7 minus 4 is 3. And then here I have a 4. What's 7 choose 4? Let's see. 7 choose 4. I have this as 7 factorial over 3 factorial, 4 factorial. 7 factorial, 7 times 6 times 5 times 4 factorial. I have a 4 factorial at the bottom. My 3 factorial is 3 times 2 times 1. 7 times 6 times 5 is 210. 3 times 2 times 1 is 6. 210 divided by 6 is 35. So for my first one, 7 choose 4, I have 35. For my second one, I have y to the third. And for my last one, I have x to the fourth. So my fifth number in this expansion will be 35, y to the third, x to the fourth.